Hello and welcome back to Psych 303, the analysis of everyday behavior. This lecture is the first in a series of 3 lectures for Chapter 3, Graphing and Measuring Behavior. So we'll be talking about graphs and the logic that underlies single subject design and the different kinds of designs that we're able to use during these lectures for Chapter 3. Let's start off with the idea of single subject designs. For those of you who have taken statistics, you've probably been well trained in the use of group design research. But because applied behavior analysis is an area where we deal with individual clients, we rely heavily on a group of research or treatment designs called single subject designs. And before I start talking too much about them, I think the important thing that I want to point out as we move forward is that in all research designs, what's really important is that you gather a lot of data. The more data you have, the better the picture you have about what's happening. And in a group design, typically you gather one or just a few data points from each subject. And in order to gather a lot of data, you need a lot of people. In single subject design, because we only have one client that we work with at a time when we are intervention specialists, we can't really use evidence from someone else to determine whether a treatment is working for your client. And so we rely on data collected from a single subject, from a single client. And so as a result, to get a really good picture of what's operating, we need to gather lots of data. So, with single subject designs, each client is treated as an individual. In fact, they're treated as an individual experiment. They themselves are the subject, and treatment effectiveness is really measured by comparing the individual's behavior before treatment and during treatment and possibly after treatment. There are a variety of research designs that do this in a very scientifically valid way, and we're going to talk about 3 big ones. There are more, but these are the 3 main designs. The first is the ABA design, also known as reversal designs. There's also the multiple baseline design and the changing criterion design. And you will be using one of these 3 designs for each of your projects. For your self-behavior modification project, you'll be using one of these designs. And for the cultural engineering project, you'll be using one of these designs. So it's important to really understand how they work and how they're valid. So let's start with the basic ABA design or reversal design. The basic reversal design relies on something called baseline logic. And baseline logic is the key to establishing cause and effect when using only a single subject. Understanding the baseline logic of the simplest reversal designs is going to help you understand the logic that underlies all of these single subject designs, and so it's important to really understand it. Okay, so the first step in all single subject treatments is to collect baseline data on the behavior of your client. So when your client presents to you with a behavioral issue that they want to change, we need to understand what their behavior is like before we intervene with any treatment. What is the target behavior before you begin treatment? So where do they stand in terms of the behavior that they're looking to improve? Baseline data is basically equivalent to control group data in a group design. It provides a comparison for changes that are seen during treatment in the single subject design. So in a group design, we compare control group to the treatment group or the experimental group. And for single subject design, we have baseline data that's compared to treatment or intervention data. And you can gather more than one kind of baseline data. So if you're interested in, if a parent comes to you and they're having problems with tantrums, you can gather multiple kinds of data on those tantrums. You could measure the frequency of the tantrums, the duration of the tantrums. You could gather data on the intensity of the tantrums, but all at baseline before you put together a treatment program and intervene. And so we start with a good solid picture of what the problem behavior is before we begin to develop our treatment and then institute the intervention. So in a basic ABA reversal design, the traditional method is to begin with baseline. We often call it baseline 1. We then move to treatment, and then we go back to baseline 2. So let's review each of those steps. Baseline 1 establishes, depending on what dimensions of behavior you study, it can establish the frequency of the behavior, its rate, its duration, the intensity of the behavior before treatment begins. It tells us how bad the target behavior is before we begin the intervention. Once we have a good description and an understanding of the function of the behavior and the antecedents and the consequences of the behavior, we can develop a treatment. And the next step is to go in and put our treatment in place. And this is based on our analysis of those ABCs of the target behavior. We develop and implement a treatment or intervention program, and the data from the treatment condition is then compared back to the baseline 1 condition. And we're able to show behavior has changed. At that point, we return to baseline briefly. Following treatment, the conditions are then returned back to those conditions. The treatment is removed and the conditions are returned back to the previous baseline conditions. And if the behavior goes back to the original baseline levels, then the improvement during treatment must be due to the intervention and not some coincidental variable. So that's the basic idea that underlies the ABA reversal. Now, just a few notes. Remember that whenever you're dealing with individual clients, it's not ethical to compare one client to another client. Instead, the data is compared only for a single client. So we use our baselines on both sides of treatment and the treatment conditions to determine whether or not what we're doing is working. 2, many data points are obtained in each condition. This establishes reliability of the evidence. It makes sure that the picture that we have isn't just a single snapshot, that we have a really good representation of the behavior both in baseline and in treatment. 3, returning to baseline helps to rule out alternative causes. There's always a risk when you just have one baseline and then behavior changes during treatment that it could be a rival hypothesis, that there could be an extenuating circumstances or a confounding variable that could be responsible for the change that you see. So we want to rule out any other possible reasons why behavior could have changed, and we would rather do that directly by going back to baseline and seeing the behavior return to those baseline levels and then returning to treatment so that the individual again reaps the benefits of treatment and then we maintain the treatment condition, rather than relying on statistical probabilities. One of the big differences between single subject and group designs is that in single subject designs, no statistics are required. They're optional. You can do statistics, but what we're more interested in is determining whether or not the changes are meaningful from baseline to treatment. So, and ideally, if our treatments are very effective, we should be able to see those effects graphically on a graph and see that the quality of the individual's life has been improved in a meaningful way. Now, you can do statistics, but statistics doesn't ensure meaningful change. It just ensures probabilistic reliability. So it's important to remember that when you're doing research in a group setting, you're just looking for differences. But when you're doing individual therapy with a person, you need the treatment to work not just in a statistically significantly different way, but in a meaningful way. And that's why stats are secondary to what we call visual analysis. Let me give you an example. So here is the use of baseline data for comparison and what a graph might look like. So we start out on the left with a baseline condition, and there are These are 15-minute research sessions per day, and so each of these represents 15 minutes per day over a 5-day period. And what we see is that the number of incidents of a playground aggression for this particular child is relatively high. I don't have all of the numbers there, but it's relatively high. And when treatment is implemented, we see that the levels of playground aggression begin to decline, and they decline pretty rapidly over the next 5 days. Now, there could be lots of reasons. If that were the only data that we had, just the baseline and treatment data, it could be that last week the bully was out sick, and so the target child was involved in a lot of aggression. But the following week, the bully returns and the child's aggression levels drop out of fear, and not your treatment. So we then go back to baseline. These are evidence of screaming behavior. We go back to baseline, to where it was before in terms of treatment, and we allow ourselves to then watch to see what happens. And you see that the behavior begins to climb again. That tells you that the treatment plan had a declining effect on screaming and aggression in this particular child. Now, bullying may also be contributing, so you may want to go back and forth periodically between treatment and short instances of baseline. Now, in this case, we go back for 4 days at baseline and baseline 2, the second baseline, days 11 through 14. But they wouldn't necessarily have to be that many days. If the behavior shows a tendency to return, then we can just show that the behavior is lower during treatment and climbing during baseline repeatedly over and over again. Then we're pretty certain that our treatment is what is causing the desired decline in behavior. So as you can see, graphs are important. Let me back up here. I could do statistics on these 3 conditions, and they would show me that the treatment condition is producing lower levels than the first baseline. But you'll probably notice that because it lumps all the data together, it treats day 1 the same as day 5 and day 6 the same as day 10, that it really is looking at averages and variability. And the average for baseline is at this level. The average for treatment would be only this low. And the average for second baseline would be even lower. And so the trends that you would see from a group design and from the use of statistics would not support the fact that it looks like this treatment is actually working. Because we're really looking at the trend in the data, not just its average. So there are reasons why statistics distort the evidence by treating all of the data points in a condition as if they are the same. There's no temporal sensitivity for them. So statistics will not necessarily give you the result that you see when you look at a single subject graph. That's why graphs are so important in ABA research. Single subject design graphing is different from group design graphing. Data should be graphed and reviewed every single day because you want to see today's data within the context of what's come before. The time is always the bottom of the graph. That is always what's going across the bottom. And by graphing this way, it helps you determine whether behavior is stable or whether it's increasing or whether it's decreasing. It helps you to see whether or not your treatment is having the desired effect. And it may be a cumulative effect that takes several days or sessions before it actually reaches its final stable levels. It helps you decide what needs to happen next, and it helps you see what happens after your treatment is removed. And you can't get all of that information from statistics or from a group design. Let's look at an ABA reversal graph and talk about the different pieces of the graph so that you have a good understanding of what these graphs are supposed to look like. So this is actually a real graph from an article, and this is what they called figure 5, and these are the rates of hitting behavior. This is self-injurious hitting during baseline and the blocking treatment condition for a subject named Arlo. And so let's talk about the graph. First, we want to look at the axes, and I'm going to use my little cursor here. So here we have the y-axis, or the vertical axis, and it is the number of hits per minute. So 1, 2, 3, or 4 hits per minute. He never gets above 4, so that's where the graph starts. And our horizontal, or x-axis, is across the bottom here, and this is the number of sessions. And the number of sessions that go across the bottom here range from session 1 all the way to session 35, which is probably a month or a month and a half's worth of data for this individual. And of course, our ABA reversal design intervention begins with baseline. So our condition labels are up here, and note that we go from baseline to blocking to baseline to blocking to baseline to blocking. So this is a study in which they had 3 complete reversals from baseline to treatment across a 35-session intervention. Now, when you change from baseline 1 to the blocking 1 condition, we put in something called a condition change label or line. And it's a dotted line that runs between the last data point of baseline and the first data point of the blocking treatment condition. It doesn't, and you'll note that the data point between the end of baseline and the beginning of blocking are not connected. And that's because the conditions are different. And so these data points are not really related to each other. And you'll see in baseline 1 that his hitting rate per minute is relatively high. And when the blocking condition is put into place, that the number of hits per minute drops quite low. We then go back to baseline to rule out those confounding variables or coincidental variables. And so there's another change line, condition change line. The data points between the two are not connected. And again, we start to see the behavior climb. And the lines between each of the data points, that line that connects data point 2 to data point 3, is called a data path. And after 5 days at a return to baseline, we have another condition change line, and we return to blocking again, and the data once again drops. And each one of these dots represents the average amount of hitting per minute in that session. And notice that now that we've come back to the blocking design a second time, not only has it declined, but it begins to approach 0 by the end of the condition, which is really good. With self-injurious hitting, you want to see the behavior come down, but you really want you want no behavior. You want no hitting if possible, or as close to no hitting as possible. They then return once again to baseline, and you see the behavior kind of start to pop up again, but in anticipation, it returns again. We come back to our last blocking condition, and the behavior remains very, very low. So what happens here is, if there were a coincidental variable that was responsible for this behavior, then you would have to argue that that coincidence occurs whenever the treatment is put into place or taken away. Here we have 6 days of treatment. Here we have 3, 4, 5, 6, 7 days of treatment. And here we have 6 days of treatment. Look at the number of baseline days. Here are 5 days here. There are 5 days here, but there are only 3 days here. And you can see that behavior is consistently higher during baseline and lower during blocking. And so as a result, we can see that there is definitely effect of the treatment happening in these 3 conditions. And we can also see all of the pieces of the graph that would be important for the behavior analyst to record and use to show supervisors, colleagues, parents, clients, how behavior is changing and how his treatment is actually affecting the behavior. So it's very effective. So when it comes to graphing the data, you first use your data collection sheet to gather your data. Then you graph those data points onto your graph. Your data sheet and your graph should have 100% correlation. The data on one should match the data on the other. really, you should even include missing days or missing sessions. They should be visible on your graph and on your data sheet. If you have a missing data point, say B, then you say B, you didn't gather data on that day, you just draw from A to C. So if you have a Monday, Tuesday, Wednesday, Thursday, Friday intervention, and the student is absent on Tuesday, you would draw the data point from Monday to the data point on Wednesday and just go over the blank spot for the missing Tuesday. Always keep a pen and pencil graph for your daily graphing. You don't need to print out a brand new computerized graph every single day. When you have, if you're going to become, for example, a school psychologist, you might have 32 kids that you're tracking on a daily basis, and you don't need a new graph for them every single day. You really only need professional graphs when you get to the end of an intervention or the end of a treatment, and you're going to present information. Otherwise, you can keep it all on just graph paper and with pen and pencil. There's nothing wrong with that. Enter the data into a graphics program at regular intervals, such as at the end of each condition or prior to meetings with the IEP team who are going to talk about the child. You might want to have professional graphs at that point. So, but really a pen and pencil graph is perfectly sufficient for daily calculating. When you do it in a graph, there's a temptation, in a computer program, there's a temptation to just wait until you get a few data points and then enter them all. And the problem with that is that in those 4 days that you waited, something critical could have happened and you missed it because you weren't graphing your data. So it's important to graph every single day. Okay, research or treatment. What exactly are we doing here? Are we doing research or are we doing an intervention? And in behavior analysis, we really are doing both. In ABA, all interventions are research-based. Everything you do for every client should be based on evidence. The goal of ABA is to use this experimental approach in the treatment of every single individual client in order to determine whether that treatment is working as hoped it would for that individual person. You can have evidence that it works for 15 people, but if you aren't gathering data on your newest client, you really aren't, and you're just putting an intervention in and saying it better work, then you're not really ethically living up to the standards of applied behavior analysis. We want to make sure that every single client, we make every decision based on the data. ABA doesn't treat a client or a patient or a subject like the mean and the standard deviation of some other group. We don't say it worked for that group, so it should work for you. We might assume that it will work for you, but we use our data that we gather to determine whether or not it's working. And if it's not working, then we go back to the drawing board. Everyone is an individual. We all bring unique characteristics to whatever setting we are in. No comparisons across people in ABA. We don't do that. We can look and say, gee, the same effect happened for 4 people. This implies that the treatment is effective, but for the 5th person that we choose, we still collect data. Every intervention constitutes its own complete experiment. It's really important that we only compare each client's improvement to their own baseline measures. All right. So that's kind of the logic for the underlying mechanism of using ABA reversal designs. So, but there are quite a few of these designs. So in the next lecture, I'm going to talk about a series of types of research designs. I'll talk about the AB design. I'll review again the ABA and the ABAB reversal designs. We'll talk about the multiple baseline design, the alternating treatments design, it's sometimes called the multi-element design, and the changing criterion design. There are a lot more of these kinds of designs that are used in behavior analysis, and they are combined with each other and can become quite complex, but they're not usually taught until someone decides to go to graduate school. So we'll cover the big ones so that you have a good fundamental understanding. So that's it for today. Have a great afternoon, and we'll see you back for Lecture 3B.